That's partly why AAA has partnered with or joined a coalition of organizations that you'll see here. This is just a sampling of the organizations that have committed to less hype, focus on the facts, and consumer education. So all of these organizations have come together to form Partners for Automated Vehicle Education that launched earlier this year. It's solely focused on education. It's not an organization that's lobbying for any particular technology or any particular policies. It's solely about we've got to get the right information and the facts out to the public and provide some opportunities for people to see, touch, feel, and engage with this technology when we can. So there's been one demo event sponsored by PAVE, and we're looking potentially to do more of those kinds of events around the country in the future. We think the public education and the exposure to technology is very important. Public trust in technology will be important for acceptance of the technology and broad adoption of the technology. So I'm going to talk a little bit about some of the things AAA has been doing, some of the surveys and the research that we've been doing to get a better handle on public attitudes and how technology is being implemented and how we're engaging with it. For the last 4 years, as Kathy mentioned, AAA has been doing a consumer AV survey to gauge public attitudes about self-driving technology. Others are doing similar work. HNTB has been doing some good work on this front as well. And I think we're all coming to some similar conclusions about the importance of consumer education and exposure to technology. Our surveys show that 71% of respondents fear riding in a self-driving vehicle. That number hasn't changed a whole lot since we started the survey 4 years ago, but you will see the dip at the end of 2017. And that's when about timed with the fatal crash in Arizona with the self-driving Uber vehicle, which I think prompted a little more fear among the general public. But we'll be interested to see how that trend might change in the years to come as more people get familiar and exposed to some of this technology. The good news, I would say, is that we also ask about exposure to and understanding of technology. And our survey shows that as exposure to current technology increases, support for and comfort with technology increases as well. And I think that's good news because there is a lot of great safety technology already in vehicles today that we need to be taking advantage of. If you own a model year 2018 or later vehicle, it's likely that you have some form of driver assistance or support feature technology in your car, like adaptive cruise control, automatic emergency braking, or lane keep assistance. We estimate that about 93% of 2018 vehicles are equipped with at least one driver assistance feature. Show of hands in the audience, how many either own a vehicle or have driven a vehicle that has one of these features in it? So quite a few. So I'll be interested to hear maybe later if you like them or frustrated by them or have had any bloopers with them. So while there's a lot of important work that needs to be done to advance, the fully self-driving technology, we also need to make sure that we're getting the full benefit out of these safety technologies in the cars today, and that we don't confuse fully self-driving with driver assistance. And that's been the focus of a lot more of our research. Oops. I don't know where that one came from. So AAA and the AAA Foundation for Traffic Safety are conducting research on vehicle technologies and testing the technologies to better understand their capabilities and their limitations. And we're finding variation in design, in implementation, and naming of the technologies, which can add to consumer confusion. So our automotive engineering group has done testing on blind spot monitoring, automatic emergency braking, self-parking, and other technologies. And as I said, find that every OEM implements it a little bit differently. In some cases, automatic emergency braking can be implemented slightly differently even within one OEM. But in some cases, the braking might be designed to slow a vehicle and lessen the severity of a crash. And in other systems, it might be designed to stop the car and prevent a crash. It might seem like a subtle distinction, but it's an important distinction that the owner or driver of the vehicle should understand because it could have implications for safety. And they found that the technologies aren't perfect. They don't operate or they aren't effective in all scenarios. Some are better at detecting certain objects than others. Motorcycles are a little harder to detect than passing large vehicles. So there's a lot of nuances with the technology in their effectiveness and how they perform that it's important for us as drivers to understand. And as I noted earlier, at least one driver assistance system is, like automatic emergency braking, is available on about 93% of new vehicles. One other project we did looked at 34 vehicle brands sold in the United States to identify the number of unique names that manufacturers use for advanced driver assistance system technologies. This is one example here. Automatic emergency braking, which is standard in 31% of 2018 vehicles, has 40 different names to describe it. Adaptive cruise control, lane keep assist, and blind spot warnings have about 20 different unique names. And the marketing names that manufacturers are using don't always make clear what technology is present and how it functions. An example, can you tell me what active distance assist distronic means and what it does? Or Presense City, what does that do for you? Turns out those are adaptive cruise control type systems. But you wouldn't necessarily know that unless you read your owner's manual or spoke at the dealer before you left after purchasing your vehicle. So I think it's important to really understand what the naming of these technologies is. And a similar survey that AAA did found that about 40% of drivers expect driver support systems with names like autopilot, ProPilot, Pilot Assist, that has the ability to drive the car itself. Those technologies, none of them are intended for the driver to disengage and not pay attention. So we have some challenges there. In response, we've developed a list of recommended names and definitions for driver support systems that are simple, specific to what the technology does, what the functionality is, and we're engaging with other stakeholders, with industry, to try and get consensus and implement some of these common and simple names. And I think as the technology becomes more prevalent, as more of this is on vehicles in the future, it's going to be really important to have terminology that reflects what the function of the technology is. And that'll help consumers understand how, when, and why they're supposed to use that technology. Understanding that technology standardization and naming standardization is going to take time. In the interim, we still need to educate consumers on the capabilities, the limitations, and the variability in the technology, and we're committed to doing that. As I've said before, misperceptions about the technology can lead to improper behavior and use of the technology. The AAA Foundation for Traffic Safety worked with the University of Iowa last year, released a report that surveyed over 1,200 owners of vehicles, late model vehicles that had advanced driver assistance system technologies in them, to understand how they use them, what their familiarity with the technology was. This was one of the findings. That 25% of drivers that had forward collision warning or lane departure warning systems feel comfortable engaging in other tasks while they're driving. Keeping in mind, this is a warning system, not a system that will engage for you and take action. Similarly, 29% of people reported that forward collision warning systems in their vehicles could apply the brakes in case of an emergency, which it cannot do. So that lack of understanding and confusion about the proper function of the technologies can lead to misuse and over-reliance, and we need to address that. I'll touch on, just to conclude, a couple of additional upcoming research projects that we have both on the AAA side and the AAA Foundation for Traffic Safety. We're doing additional testing of level 2 systems in vehicles getting that underway this year, and we'll be reporting those findings early next year. Again, kind of testing how the systems perform on test tracks and in real world situations, what the capabilities and some of the limitations were. Also, we'll be releasing a report in October looking at pedestrian detection technology. There's a lot of interest in that technology. Pedestrian fatalities have increased significantly, and we need to do something to address that. So looking forward to seeing that final report and what recommendations we might be able to make in that regard. As well, AAA Foundation for Traffic Safety is really focused on how are humans engaging with this technology and what do they understand about the technology. We've got a few projects underway that I think will provide very interesting results for us. One looking at the potential for distraction and fatigue to come into play as drivers become more reliant on some of these systems. We have a couple of different projects underway to look at that, one of which is going to provide us with video footage of people driving these vehicles with these systems to see exactly what's happening if you're on long trips and don't have to or feel that you don't have to be responsible for driving every moment. What does that mean in terms of your awareness, fatigue, what kinds of things set in? So we're looking forward to learning more about that. We're also trying to understand how people are learning about these new technologies. Is it at the dealership? Is it online? Is it other sources? And what are going to be the most effective ways to train people on this new technology going forward? I'll conclude, I guess, by saying, reinforcing that AAA is very excited about this technology and the future potential to have dramatic improvements in safety and mobility options for those who maybe have not been able to drive or might need to give up driving in the future. As more fully automated vehicles like the shuttles we've talked about, and I know that Aaron is going to talk about ride-hailing fleets, enter the market, and more level 2 driver assistance features are becoming available and standard features on cars. We're going to have mixed fleets out on the roads, and so we need to understand how the interactions will happen and really understand what our responsibilities are as drivers before we get to that future nomadic state that we might be in. So I'll conclude there and thank you for being here and turn it over to Aaron.
All right, folks, we're just moving right along. Thank you very much, Jill. So this is what I took from Jill's presentation on all this new technology, self-driving, and people thinking they can watch Netflix and that sort of thing. Education is key. Thank goodness we're having seminars like this now. But we certainly have to reach a lot more folks because I can see folks take advantage of these new technologies that are implemented in our cars. I'm old school, so I still don't even use the backup camera. I'm scared to use the backup camera. Or the little thing that tells you there's a car going by. I mean, I still look to the side to make sure there's not a car going by. So I'm still old school. I'm learning. But we know there are folks out there who are not like that. So this is great. But I think we might need to take this seminar to Netflix so that we can get hold of everybody and educate them on this stuff. So our final presenter today is Aaron Foster, Solutions Engineer with Navya Group, a France-based global leader in the autonomous vehicle market and fluid mobility solutions. Aaron is based in Michigan. He joined Navya in 2017. There he works with the business development team to develop and validate opportunities with the company's current operational design domain and from a legislative standpoint. Aaron also works to educate potential customers, the public, and the industry, and lobbies legislators on the benefits of first and last mile mobility, connected vehicle technology, and automated vehicles. Please welcome Aaron Foster.
All right, good morning. Thank you everybody for coming out to the seminar today. This is actually the second Technology Takes the Wheel Summit that I participated in with AAA, so Thanks again also to AAA for coordinating this event so we can really tell people not only, as we've mainly discussed to this point, what does the future look like? And today I'm going to take a little bit of a step back from the OEM's perspective. Navya was the first company worldwide to commercially deploy a shared autonomous vehicle back in 2015 in the country of Switzerland. Since then, we still remain the largest fleet worldwide of low-speed automated shuttles. And I feel that the shuttle market is really one that doesn't get as much of attention as some of the other companies like the Waymos and the Ubers of the world, just because traveling 20 miles an hour just doesn't have as much sizzle as being able to go from state to state, things like that. But ultimately, I myself, also Navya, obviously we feel that the connected sort of mobility within the first and last mile is ultimately going to be a great way to usher in everybody else in the boat to do the highway, the long hauls, the trucking, things like that. So that being said, we're really looking at an increasing trend towards urbanization. We're going to have about 70% of the worldwide population gathered within these urban areas. And if we keep doing everything the way that we are today, we're just going to see increased congestion, pollution, and continued reduction in availability for parking and real estate within these urban areas. So if we are able to become more intelligent, become more fluid and multimodal with our transportation within these urban areas, we're going to be able to reduce all these. So if we have fewer single occupant vehicles on the road, we're obviously going to reduce congestion. If we have less congestion and people idling within these urban areas, that's when we're doing the worst pollution and the most damage to our internal combustion engines. So we're going to see an increase in the local environment. And then also, as we have fewer vehicles being needed to be driven from point to point throughout a city throughout the day, we're going to see a increased access to parking, and eventually we'll be able to see some of these parking facilities converted into alternate use facilities, whether this is residential, business, or converting back into green spaces as well. So just a couple facts on why we are looking for automizing our transportation. NHTSA says 94% of all motorway accidents are caused by human error. There's very few reasons that an accident is really unavoidable. It would have to be environmental or a true product defect. That means that we can save almost 40,000 lives a year by automating and removing those sort of human decisions, the distraction, the sort of just lack of attention to the road. We can see through AAA, 1 in 5 drivers have been in an accident where somebody's had to go to the hospital. So this is a significant drain on our resources from a productivity standpoint, and then also just from the emotional and sort of effects of being involved in one of those accidents. And death by motorway accident is the #1 cause of death for otherwise healthy citizens in the United States. So this is really an area where we have a huge opportunity to improve. Now, when companies like Navya can automate and do the first and last mile, we have a lot of benefits when we're shared. We have benefits of electrification from an efficiency and an environmental standpoint. And then when we move to the days of on-demand, we're going to be able to be much more flexible with our fleets. There's a tremendous amount of data out there that cities can make available to companies like Navya, so we can know from day one where are the sort of gaps within the transit system, the deserts, these first and last mile gaps. And we can provide upward economic mobility to people that are living in underserved communities where they just don't have the means to get out of those neighborhoods. We can provide equitable mobility. We can enhance the passenger experience because not only is it safer, but you're not having to worry about rushing to find your next parking spot. You're not going to be driving around the block looking for that next place to park. And then also from an operational standpoint, when we're removing the drivers, we are removing that cost, but we're also reducing costs because we're just going to have fewer accidents, more uptime for our vehicles, less repairs required, things like that. And Navya has been successful so far in a wide range of places. We're in cities, campuses like airports, hospitals, industrial sites, places where people are taking a lot of quick trips throughout the day. Maybe about a half a mile up to 3 miles is a perfect wheelhouse for an automated low-speed electric vehicle. Now, what makes Navya different from a lot of the other companies that you're familiar with is we are truly a vertically integrated OEM. We're not just focusing on the software, we're not just focusing on the vehicles, and we're not buying companies out there that have already got technologies. We created the design of our vehicles, so that's important because we're about the same size as a minivan, but since we don't have a internal combustion engine, a front or a rear to the vehicle, instead of only having a 7-passenger capacity, we have 15. We do our own software, so that means we have full revision control. We can do over-the-air software updates to continue improving the experience and the safety levels of the vehicle. We commission and put the vehicles on the road, which means we have full visualization into how these vehicles are being used on a day-to-day basis, and can provide feedback to those users in how they might be able to get a little bit more utilization out of the vehicle. And then from a connectivity standpoint, we've developed our own mapping system, our own back-end system, high-level encryption, so it is a very secure system from a cybersecurity standpoint. So we do have 2 headquarters. So we are a French company, as was mentioned in the introduction, but I was actually brought on with the company to start the North American subsidiary. We're just outside of Detroit, and we're there for a few different reasons. Number one, we have manufacturing for the United States and Canada, so access to the supply chain in that region is second to none. Also, just the talent from a manufacturing and maintenance standpoint is also second to none. We've got over 300 people working for the company now. We've got a little bit of outdated numbers on this. And we've got about 130 vehicles right now operating in 26 different countries around the world. Now, it's not just nice to say that we're operating in 26 countries from a marketing perspective, but since these are intelligent systems, all the data that's collected from one vehicle is shared throughout the fleet. So all the miles that we drive in Singapore, we're going to learn different lessons. There's going to be different vehicle and pedestrian behaviors, different weather conditions that we're going to experience in Colorado versus Quebec. Versus Australia. So we get a really good, rich data set out of having a worldwide fleet distribution. And recently we announced that not only are we focusing on manufacturing the vehicles, but we are going to be providing our software to third-party companies as well. And this is important because the more vehicles that are operating our system, the more data we're generating, and the more quickly we're able to progress to the next level. And the first example of that is our partnership, our subsidiary with a company called Charlotte. They make airport ground support equipment, so we've upfitted one of their vehicles that tugs luggage around airport tarmacs, and that's going to be doing the first tests later this year. So we've actually developed 3 different vehicle platforms. For North America, really what we're focused on is, again, the first and last mile, so we've got the Autonom Shuttle. That's considered a level 3 automated vehicle. So it really can be driven. There is an attendant on board who's actively monitoring the road, but we actually don't have any traditional controls. So there's no steering wheel, pedals, gauges, and the automated system is really designed to do the lion's share of the driving. If there's ever a situation it's not able to negotiate, it'll actually just stop in place and require that operator to take over. We also have released our Autonom Cab, which is a level 4 vehicle currently testing in France and Australia. That's really in more the same vein as what the Ubers and the Waymos of the world are doing. This is going to be all app-based mobility. We're going to operate still within a geo-fenced area, but we're not going to be on a fixed route. So we're going to be able to dynamically pick up passengers and reroute ourselves based on both demand and traffic patterns. So just giving an overall view of the marketplace, some of the companies that we are working with here, this is an absolutely massive opportunity. We're looking at, close to $500 billion in less than 20 years from now. So there's definitely going to be some winners, but one thing that I also want to point out with this slide here is that for every manufacturer that you see on this list, there's really no standardization between the two of them. So we are really in desperate need of standards, and groups like the SAE are really working to help standardize messaging and things like that so we can work together. This is just here to give you a basic idea of our global footprint. I mentioned that we're operating in 26 different countries. Another advantage that gives us is that each country is essentially going to have their own requirements for how secure does the vehicle need to be, how safe does it need to be. So we've had to go through many, many trials, and we feel that at this point we've got a vehicle that, while it may not meet the federal motor vehicle safety standards in the United States, We are still receiving waivers from that because we've been able to give data to the agencies showing that we are able to maintain at least the same baseline of safety. And if you actually look at our operational record, we've been operating in 26 countries, over 100 shuttles, we've moved hundreds of thousands of passengers, and we've actually never caused an accident. We've been run into before. Someone's literally walked into the side of our shuttle and it makes front page headlines just because we're an automated vehicle. But you know, these are just the things that we're dealing with. So just examples, you know, we are working with universities. University of Michigan, you'll see under the campus category, they were our first customer here in North America. And we followed a tiered sort of rollout with the university. They've got a site called M-City, which is a proving ground specifically designed for connected and automated vehicles. So they've had 2 of our vehicles there for about 3 years now, have integrated into some of their research programs, added their own sensors, ran them through just dozens and dozens of different scenarios just to see how the vehicles would react. They felt safe enough with these that they decided to purchase 2 more, so now today we're actually operating on the open roads in the normal flow of traffic up on their North Campus Research Center, where we're bringing students and faculty from remote parking lots to different buildings across the campus. And that's going to be scaled up through most of the rest of the campus over next year as well. Well, you'll see, you know, other places. Las Vegas was a city where we did a year-long pilot that was sponsored by AAA, and we got a tremendous amount of feedback. AAA was doing a lot of surveying of the riders, and one thing that was very nice for me to see was that there was about a 30% increase in consumer confidence pre-ride versus post-ride. So when you're on our type of vehicle where it's on a fixed route, it's low speed, it's within a fairly controlled environment, people really start to get the sense of, okay, computers can make these decisions, so let's make sure that we're doing it right, and then move up from there. So people are almost never still afraid of automated vehicles as a whole after riding in low-speed electric. So just to give a little bit of a high-level overview of how a system like ours works. Much like an airplane system, we are going to have sort of complementary and redundant systems that are going to help out. So at a high level, we've got perception, decision, and an action system. Perception is going to need to know where it is within its environment, and it's going to be able to see any obstacles that we're going to need to avoid. So for this, we use a GNSS antenna for satellite localization. And when we have access to a fixed reference point, whether this is a high accuracy GIS network, or we can install our own hardware as well, we've got about a 3 centimeter degree of accuracy when we're operating in one of these environments. And this is very key because we're not a very camera heavy system. So when we're able to localize within our few centimeter degree of accuracy, we're able to operate in places with snow because lane lines get covered up and we don't want our system to be looking for a line that's not going to show up. Stop signs and bus stop signs can get knocked over, so all of this information is really encoded as satellite positions. Within that perception system, we've also got obstacle detection, which is going to be handled by LiDAR units. We have both 3-dimensional and 2-dimensional. And we're going to be able to treat any object that's about 30 centimeters or taller as safety critical. We don't want to, at this point, differentiate between if we're stopping for a dog, a bicycle, a vehicle, really anything in our way. We want to yield the right of way to that obstacle. So that's one of the reasons that we've been able to maintain that extremely high level of safety. So once all that sort of perception data is gathered, we're feeding that into the decision system, which is by nature of its name, going to make the decision about where it needs to go, which will then send commands to the different electronic components in the action system. Also, in terms of redundancies, if we're ever losing localization through satellites, we can use our LiDARs to find our position. It'll essentially triangulate using, you know, thousands of different points in the local area. And if that system even goes down, we have an inertial measuring unit that can operate the vehicle for a very limited amount of distance until we've either regained the satellite connection or have had a human operator take over at that point. So we really want to make sure that, you know, worst case scenario, we do have that person on board that can take over. But we do have a few cascading systems to make sure that, you know, they're taking over as few times as possible. We're generally averaging about 99% of all of our miles using the full automated system, and only about 1 to 2% of our miles are driven manually in our vehicles today. So here I just wanted to show a quick video. This is just a couple minutes long. It's going to show some videos of the shuttle working in the real world, because a lot of people think that, we're operating on test tracks and that's all and well. But to see these actually operating on the road in real world conditions is something that people generally like to see. So I'll just go ahead and run through that here right now. So a few of the shuttles that you saw in the video, there was a blue shuttle. That was our one that we had out in Las Vegas for the AAA demo. But then we also went all the way back to the yellow shuttle, which is our first that we had deployed in Switzerland back in 2015. So that service is actually still ongoing today and has been expanded up to about 4 or 5 different lines that they're running throughout the city. So this really is here. We're going to continue growing and expanding our product line, but I want to thank you for your time and open the floor up to questions at this point.
All right, folks, get your questions ready. Our presenters will answer your questions now. I know you have to have some. I have a lot. Wasn't that interesting? Man, I am so excited. Oh, folks have their hands raised already. I don't know about you guys, but a lot of this futuristic stuff gives me the thought back to the Jetsons. You guys are probably too young to know about the Jetsons. But I remember watching the Jetsons a few years back, that futuristic show, which was so cool. It's hard to believe that people were thinking about that stuff in the 60s. And here we are in 2019. All right, are we ready? You guys ready for questions? All right, hands up. Guy in the green.
I see you're investing, thanks. You're investing all your money in the technology and the things. What about the people the humans that'll be displaced job-wise and work-wise? Have you put any thought into that?
Sure. So this is a common concern. If we're essentially removing drivers from vehicles, these are people that are often paid to do so. So I see a similar sort of situation when we were automating elevators actually decades ago. There were hundreds of elevator operators that were just essentially, even when we switched to push button, they still wanted somebody in the elevator to push that button. So since then, we've been able to essentially retrain. And also, since I think this isn't going to be just an on-off, it's going to be sort of a ramping up, we're going to have the opportunity to, train drivers to become technicians or software engineers. And actually, Navya is working on a program where we will actually retrain any driver who is displaced by our shuttle service being deployed. So it's something that we're very, very concerned about.
Well, yesterday I was learning some 5G technologies, and that will be the communication need to get all those things running in timely and without interruption of communication. How far we are that implementation of 5G whole United States? Anybody has an answer?
So 5G, I mean, there's a few cities that have started to roll out test beds, places like Toronto and things like that are really seen as smart cities. I know Wichita is actually, through one of the other telcos, going to be getting some 5G here pretty soon. So that's definitely, that low latency, high-speed connection is going to be essential not only for things like V2X communications, but also being able to offload the processing from these automated vehicles is going to make the cost of just deploying them much, much less, because we'll be able to do all this processing in the cloud rather than on the vehicle.
Thank you.
You guys mentioned having to put money into infrastructure so that there are communications between vehicles to vehicles and things of that nature. Is there maybe a segue point where you would have a remote operator who, similar to, like, now we have the Google Glasses, the Be My Eyes programs, IRA for individuals who are blind or visually impaired. Is there something in the works maybe to have that be a transition point where they have a remote driver for vehicles, similar to like remote drones and things like that?
Yes, there is things in action already for that. And you know, and it's kind of unique because one of the things that I usually show when I do present is the Super Cruise option for Cadillac, for instance. If that, it has a camera on the center console of the car that watches you as you drive. If you turn away from that for some period of time and you don't respond and come back, it'll actually start to pull that car over and call the Cadillac, what's the Chevy? OnStar system, to actually bring emergency personnel to it. So yeah, those systems are being talked about and they are being implemented as we speak.
And from a capability standpoint, all of that technology exists. We can do remote operation today. In fact, there are some companies that are doing that, especially within trucking. But Navya's main concern, and we can do this today as well, is really the public's, comfort level on the vehicles. Having that human operator on board really is that just person-to-person communication, that there is somebody on board who not only can take over, but they probably got some technical expertise in case they need to do troubleshooting, things like that.
I'm an old car guy, but I don't see anyone focusing on the application of this technology to the existing millions of vehicles on the street today. Are we all going to have to purchase new vehicles or rent one, or what's to become of our old cars?
Well, I'll take a stab at that one. Since 1996, most vehicles have capabilities to have actuation and automation of many of their current functions, steering, braking, etc. So there aren't too many vehicles out there pre-1996 anymore, but certainly there are some, all right? And I just got back from the Woodward Cruise and Dream Cruise in Detroit, where 40,000 of those vehicles were on the highways. But it was a parade. So, we could have a permit and allow those vehicles to operate. But nonetheless, there are opportunities, I think, to retrofit. For example, the buses in New Jersey Transit are being retrofitted. Vehicles for the safety pilot model deployment in Ann Arbor, Michigan were retrofitted with equipment to allow them to communicate with each other and with the infrastructure. So those opportunities exist, and it's a business opportunity for those entrepreneurs who can come up with a kit that can go out there and say, hey, I want to automate my car. Well, that's an opportunity for them to think about.
One of the companies that's out there right now is Mobileye. It's actually an application that you can put into cars today, and it's developed by Intel, and it's not too pricey. It's about $1,000, I think it was, or $2,000. But it's actually out there, and you can put in cars already.
Can you tell me what you think the trend will be more with regards to camera-based versus sensor-based or GPS-based? What's most out there now, or what you think the trend will be in the future? Like, I think Tesla, isn't it, more camera-based right now?
Yeah, correct. There's There's really no sense in my mind of where the industry is going to go because there's really no standardization. You've got companies like Tesla that are using cameras and radar. You've got companies like Navya that are using satellites and LiDAR. And then you've got others that are using a mixture of all three. So there's really sort of unique, how do I say? There's ways that they can complement each other. So I would imagine in the future, you're going to see more systems that are going to be along the lines of a Navya's, where you're using cameras, you're using satellites, and you're using LiDAR. Really just the more data that you can have, the better for an automated system.
Yeah, and a lot of it has to do with sensor fusion. So what you want to do is be able to take the data from all those sensors and they help validate each other. So that's part of it. The other part of it is that each one of those sensors or sensor types may have a different purpose within the vehicle. So, you know, you could have LiDAR that maps your environment 360 degrees, but a radar system only looks at a cone of vision ahead of you, ahead of the car, or along the sides of the car, for example, for different purposes. So it does depend on the actual function of that sensor in the vehicle. And so that's why it's also important to have a mix of different sensors that do different things to improve the safety and operation of the vehicle.
And one other thing that another twist on this that I would add from the perspective of if, as more of these technologies are on vehicles and to the extent that they are still personally owned or even fleet-owned vehicles, for an individual car owner, understanding what those technologies are, where they're placed in the vehicle, and how to maintain them. Because if you've got cameras and sensors and LiDAR and radar, for it to function to the best of its abilities, that technology, it needs to be, cameras can't be obscured. And unless you live in a part of the country that has no dirt, no snow, no rain, no inclement weather, those cameras, those lenses and sensors are potentially going to get scratched and dirty and covered with snow and blocked with ice. And if the technology doesn't function effectively in those circumstances, we need to know that.
Can you speak to cybersecurity with computers controlling cars, both on the domestic side and also on the international side, foreign governments interfering with our lives? What are steps being taken now from maybe a coalition perspective, but also from a company perspective to really harden the technology from hacking and cybersecurity attacks?
So from the OEM's perspective at Navya, we know that there's really no system that's completely impenetrable. We've seen non-automated systems been hacked. For instance, Chrysler a few years ago, their Uconnect infotainment systems were able to be accessed, and then steering, braking, you almost had full functional control of the vehicle. That being said, Navya, we send everything through essentially dedicated VPNs that are our own. We have our own cloud system, and we've also designed the vehicles to accept as few incoming commands as possible and really air gap those systems. We don't have any Bluetooth. There's really no way to wirelessly access. So anywhere that we've seen a window, we've done our best efforts to shut it. And one of the ways that we've been able to see all of these different vulnerabilities is through internal testing, but also third-party testing with all of the foreign governments. So that's really given us a leg up from a cybersecurity standpoint.
And from a connected vehicle standpoint, standards are being developed and becoming more mature for a security credential management system. So it's really about communication between trusted entities. And so it's a security certificate management system. So each entity in this system, in the network, has to have a certificate in order to communicate with another entity within that network. So what it does is basically block out anybody else that's trying to enter that network. That's one. And then two is, and this goes to the debate on now opening up the 5.9 gigahertz spectrum, which was reserved by FCC for vehicle-to-vehicle and vehicle-to-infrastructure communications. Having a dedicated spectrum also for that purpose increases the level of security. It's not, as Aaron pointed out, impenetrable, but it does help and provide another layer of security.
And one other thing I would add on that front is industry has come together to form a sort of consortium to try and address this on a proactive basis. The Auto ISAC, it's the Automotive Information Sharing and Collaboration, is that the C? And it's modeled after similar ISACs in the financial services industry. So there's a commitment to sharing information if there's vulnerabilities that have been identified or hacks that have occurred, sharing information among the industry to try and address the problem and prevent that from happening on a more widespread basis.
Mike, can you talk a little bit about how the state might be approaching more of the balancing the traditional request for new infrastructure and redesign money going towards that, and what might be better leveraging of resources for some of this new technology? And then how does the public sentiment build into that? How do we start changing this paradigm?
I'll start out by answering that last part. I think changing the paradigm, we have to kind of let them experience it. That's come I want to do testing in the state first. Bring it in, let people kind of see, put their finger on it, ride in it, do whatever they need to do to get to a comfort zone, and then do all the education we can. You know, one of the things that I'm currently doing is talking to a lot of universities. How can we start bringing it into the universities and start talking to the students and letting the students start putting their fingers on this? You know, KU does have a simulator that's a real car. It's a Honda Pilot. And so hopefully we can make some advancements through that to try to help accepting automation in the future. As far as KDOT, you know, one of the things that we're really struggling with today is staffing. We currently there's areas in the state that have 100% turnover on equipment operators, which are snowplows and all that, are operators that do that. And so, you know, technology is going to have to come in and help us somehow. Some of that's going to be technology, some of it's going to be business processes, some of it's just going to be a different way of doing business. The prioritization, you know, maybe not every road gets plowed. Maybe we just plow the priority routes. And so we're doing a lot of that look right now. We have a piece of our staff that's looking at prioritization of snow removal. And then also we're looking at how to prioritize our staff the best we can in the rural parts of the state to try to get the most benefit of what staff we do have. There's also a look into, you know, how can we bring more people into the agency to help with that, those functions. Is it pay? Is it, you know, more benefits within the position, you know, different requirements. And so there's a lot going on in the agency to try to figure that out. As far as projects, how we handle roads into the future, we still have people driving. And unfortunately, you know, our plans, we're looking at 25, 30 years with our plans. And I believe, truthfully, there'll still be people driving then. It'll be probably the 20-somethings or 30-somethings that are out there today that'll probably still be wanting to drive. I still believe we will have a last mile. Kansas, I believe we have close to 100,000 miles of gravel road. You're going to have that last mile. Those automated vehicles don't like those bumpy gravel roads. They don't like the dirt. They don't like the dust. Okay, so we have to have some driving at that point even, because the last mile is getting home, and we have a lot of rural parts in Kansas. True, we'll have 70 to 90% is the numbers that keep bouncing around that'll be moving into the urban areas. But I fully expect Kansas to look a whole lot different in the future. I expect I-70 will have parking areas near it that the long roads, over the roads truckers will park trailers, and then you'll get non-CDL driving trucks going to the place of business to start dropping off. You start seeing remote freight systems that will be delivering in the urban areas through the alleys and the streets and kind of mixing with the pedestrians and the cars. And so it's going to look different, but I think we need to consider it, But as far as implementing it today, it would be tough.
This is for you too, Mike. Just continue on that. With the vision statements and vision plans that you put together, how does it impact the rural parts of Kansas? The Department of Agriculture had to be a part of your vision statement because a lot of our income comes from agriculture, moving cattle and grains and so forth. So I'm just wondering, how did you incorporate that into your vision statement?
Well, Department of Ag was one of the task force members, and they did get a blueprint, and they're very active. It was kind of interesting because I got an article sent to me about 2 weeks ago related to a Russian combine that is totally autonomous. And so I sent it to my partner at Ag, and they said, and they knew the company that made it. So they were going to start talking to them to see when they were going to come in the United States. So there is talk on this stuff. Agriculture is a big concern. One of the things that I've been talking to numerous people about is, are we even considering the interaction between combines and cars on local 2-lane roads in our rural area? You know, I used to be a bridge inspector. We had the big snooper machine. We'd pull it over and look underneath the bridge on the machine, and then we'd have a combine come during harvest season. Well, that was our priority, was get that combine by us. So we'd have to load up the truck, back it out, let them come through. And so there are those interactions that do change how we do business, and we're gonna have to do that. And it's the rural parts, what I'd really like to see, and I'm gonna be in talks with Aaron here, I'd really like to see one of our smaller rural communities get an automated shuttle to start taking senior citizens or handicapped people or others to points of groceries or to the hospital or to the doctor office or just to visit other people. I'd really love to see that package put in there just to see how it will work. The one thing that I keep thinking about is who's going to carry the groceries off the shuttle, who's going to, they're going to need that help. And so I was glad to hear him say that we have a person in the shuttle. So that kind of helps, but are they trained to carry stuff off? So we have to change how we do business. That's the first key piece, and we have to get people comfortable with it. And I think it will help our rural environments. And what I'd really like to do, if it helps it, then hopefully people will start moving back into the rural environment.
How do you, with the systems currently deployed, how's the experience been with inclement weather such as snow and ice?
So there's definitely some limitations from a operating standpoint, being that, at least for my company, our predominant sensor for obstacle detection is LiDAR. It's light-based. So if there's very heavy rain, especially with wind, that can create sheeting. That can sometimes create what we would refer to as a false obstacle, where the shuttle may, apply the brakes for the moment that it sees this wall, and then as soon as it goes away, would essentially resume. So you might get a little bit of a stutter, if you will. But there's also some other operational limitations just because our vehicles are battery electric. They don't like the extreme heat, they don't like the extreme cold, and we're always getting better, expanding our operational temperature range. But there are some weather limitations with the technology as it exists today.
I want to tell you a little story. I told Aaron this last night, but I was in one of his vehicles in 2015 in France, and they mapped out a route along a busy public street, and we were tooling along in the curb lane, and up ahead a cab had pulled over and had its flashers on, waiting for a fare, and of course the vehicle pulled up behind it very nicely, slowed down and stopped and announced, "Obstacle detected," just like that. And so we sat there, and it was a stalemate because the cab driver wasn't going anywhere, and the vehicle just stopped because there was no place for it to go. As far as it knew, going around it would be like driving off the face of the earth. What happened was the cab driver put his arm out the window and went like this. And of course, the vehicle couldn't read that hand gesture. And so after about 3 minutes, the cab driver got out of the cab, walked back to us, and gave us a different hand gesture. And we're all in the vehicle going, you know, there's no steering wheel, there's no foot pedals. He understood. He got back in his cab and went away, and we went off on, you know, as we should have. And so we avoided road rage. That was kind of key. So remember, automated vehicles are very polite. So a lot of the operational considerations with automated vehicles is they obey the law. Human drivers don't. And they're very polite. So, and human drivers aren't normally. At least in Detroit they're not. I don't know about Wichita. So anyway, but so those two considerations do dictate a lot of the operation of these vehicles currently.
I suspect I'm maybe the oldest one here, and if I'm not, I'm close. And so my attitude's a little different. I'm not against automation, as many people my age range are, but I'm one of those people that I like driving a car. I want a stick shift, okay? Now, how long, not limiting my ability with additional age, but how long will someone like me be able to drive their own car and, I mean, actually drive it? How long do you anticipate that'll go on?
Well, I can say I hope I never see the day when I'm not able to drive a car. I love going on road trips. I love going out on a track if I ever get the chance. So I really see the automobile becoming similar to the horse. You know, years ago, they were really predominantly used for transportation and for work purposes. Now they're largely used for sort of recreational and pleasure type activities. So I see the automobile becoming much more of a pleasure, a hobby, if you will. You know, people joining country club that has a racetrack instead of a golf course. Things like that I see in the future.
Yeah, and I would just say, I would add that I think getting to that level 5 automobile, not so much shuttles that are going to only operate in potentially defined geographic areas, but getting to that level 5 where a personally owned vehicle can drive everywhere under every circumstances in any environment in autonomous mode, I think that is a very, very long way off. And if you consider the fact that people are holding on to their vehicles longer, the average age of cars on the road today is 11 and a half years. There's going to be that mixed fleet of vehicles out on the road, I think, for a very long time.
So recently we've been having, as a society, a conversation about privacy with big tech, with Facebook and Google, and I can only imagine how valuable the data would be to know where somebody is all the time, especially when we're talking about fleets and stuff. So is the government and is the industry talking about the privacy expectations that people are going to have when this gets further along?
Yeah. One of the things we're heavily into is your private information. We don't want it, okay? And that's kind of why I'm stressing getting that pilot project going with the Internet of Things to kind of see what data we will get. Because I don't want your private data. I don't want your private information. I don't want to be responsible for that. And so we're really looking for the information that's going to help us predict what's happening on the roadway, more so than anything. Now, the vehicle manufacturer, they may have a different view on it. They may want to sell that information to others, but as far as the government, no. And we actually have a standard today that will now allow us to take the private information on it. So,
we also have a question way in the back, too.
One other thing I would just add on that topic is AAA's position on this has been that there needs to be transparency, whether it's the vehicle that you personally own, knowing what kind of data is generated by your vehicle and where it goes, who has access to it, and your ability to control that. And if in the future, if it's more fleet-based vehicles, again, that you know what kind of data is generated and captured about not necessarily both the vehicle itself, where it's going, what it's doing, but any activities you're engaging in the vehicle. If you're connected to the internet, if you're watching Netflix, you know, those kinds of shopping, those kinds of things, where does that data go and who has access to it? is going to be important for people to know as well.
Jill, two-part. So you had a chart on the deaths in America. There was a year when it was driven down, and then a little bit later it went back up. What were the causes?
It's hard to say specifically. There likely were a number of factors, but recession, I think, economic downturn is assumed to have played a part in that. Little less driving, potentially, and so less exposure.
And then since I think most of you bandied the word safety, why isn't the Department of Motor Vehicles insisting on better training? Because we're supposed to be the leader of the world, and I know of at least 2 other countries that have much more better training than we do before somebody gets licensed.
Driver education, yeah. Yeah, I mean, that's something AAA has been very involved in over the years, advocating for graduated driver licensing laws in all 50 states. So easing people into driving and making sure that they've got both sort of the book knowledge about how to drive, but the practical knowledge of situational experience. And I think we're going to have growing challenges going forward as technologies are entered into the vehicle, and the American Association of Motor Vehicle Administrators just had a conference in Omaha last week or 2 weeks ago, and one of those topics is, should driving instructors allow a novice driver who's testing for their license to use any of the technology in their vehicle to park or fulfill some of those maneuvers that they need to do. So I think we've got some real challenges in multi-vehicle households where there might be one vehicle in the house that doesn't have technology, another vehicle that does. How do you ensure that person that drives that can switch between both? Or if you're renting a vehicle or sharing a vehicle. So AAA definitely supports increased education and training. Yeah, technology's in the vehicle today. Something that we're incorporating into our driver training curriculum. So awareness of the different technologies. The challenge we have, like I said before, is that every OEM implements the technology a little differently. So it's hard to find someone who can have the expertise in every iteration of the technology. So you have to talk at a slightly higher level about the types of technology that are in the vehicle and raising awareness of what that technology is designed to do, how it operates, and how you function and interact with it.
And to add on that, I would say, demand it from your salesperson, demand it from your dealer. I mean, when I bought my truck, that was one of the things that they said was I'm going to have about an hour to go through all the safety features in that vehicle. And they're there, and I would not have known how to operate them without them walking through. Because, I mean, it used to be, in the early days, we got one driver's manual, right? Now, if you look in new vehicles, you get 6 or 7 books that you got to